Hello and welcome to our Advanced AI course. Today we are talking about the K-means clustering algorithm. We are going to learn how the algorithm works, where it is used, and how it compares to other unsupervised machine learning algorithms. Firstly, what is the K-means algorithm? K-means aims to partition a large number of elements into a fixed number of clusters, in which each element belongs to the cluster with the nearest cluster center or centroid. It is an unsupervised machine learning algorithm, meaning that the datasets used are not labeled. The algorithm clusters according to the features that the algorithm extracts from the data. Its areas of application include market segmentation, computer vision, and astronomy, and also as a pre-processing step for other machine learning algorithms. Now that we know that k-means creates a fixed number of clusters, that begs the question how many clusters we should create in order to get the best possible solution. We want to showcase two methods which help to find the optimal number of clusters in this video. Firstly, the ELBO method calculates the values of distortion and inertia for a range of clusters. The value where the graph flattens describes the optimal number of clusters. A different method is the silhouette score. It is slightly different than the ELBO method. It calculates the average distance of points within its cluster and the average distance of the points to its next closest cluster. This method helps to check how good the clusters are and can detect outliers. The score goes from -1 to 1, where -1 indicates the worst solution. So, how does the k-means algorithm cluster data? In the following steps, we want to show the k-means clustering algorithm as a practical example with three clusters. At first, we have a number of points with three randomly placed centroids or cluster centers. Each node is assigned to the cluster with the centroid that is the nearest to it. In the next step, each centroid location is recalculated as the mean of all nodes assigned to its cluster. Each node is then again assigned to the cluster with the nearest centroid. This process is repeated until the centroids are not moving anymore, indicating that the optimal clusters are achieved. Now, let's compare the advantages and disadvantages of the k-means algorithm. The advantages are that it is very easy to implement the k-means algorithm. It scales very well into large datasets, can adapt well to new examples, and can generalize clusters of different shapes and sizes. On the other side, the disadvantages of the k-means, it can be sensitive to outliers. Choosing the cluster size can be a tough job and can alter the outcome if chosen incorrect. As the number of dimensions increases, its scalability decreases. And for human visualization, dimensions have to be reduced, which can alter the plots. This has been the k-means algorithms. Thanks for watching.